Welcome to EverCharge's EV Charging 101 webinar, where we will be covering the basics of charging, as well as looking at the major differences of charging in different communities. We'll then finish up with an overview of the solution EverCharge offers. So let's get started. There are several major points to understand about electric vehicle charging that will help in understanding everything we're going to talk about today. For example, 90% of charging occurs at home or work. Public charging is not a key aspect of EV ownership, except for long-distance trips. It's key to know here, refueling an EV is very different from a traditional gas vehicle. So with a gas vehicle, we're used to driving until you have a quarter of a tank or less, and then refilling the tank to full. But with an electric vehicle, it's actually recommended to charge the vehicle as often as possible. For most EV owners with a charging station at their residence, they are only having to refuel the mileage they drove that day. We also know the average commuting worker drives less than 40 miles per day, so most charge events are actually quite short. Finally, all charging does not occur at 6 p.m. Individuals naturally have wide-ranging schedules, and charging starts and ends throughout the day and night on varying schedules that people have. So now we are going to get into the different levels of charging. Level 1, also called trickle charging, is the slowest level. It utilizes a 120-volt connection, just like a standard household outlet you would charge your phone or computer from. Charging times are very slow, only recouping around 3 miles of range per hour of charge. There are safety concerns with this level, since a lot of EV owners will use an extension cord to help reach their vehicle. With the high amp draw of EV charging, typically 12 to 15 amps, a properly rated extension cord is necessary to handle the load without risking failure. Additionally, in most electrical systems, multiple outlets are connected to the same electrical circuit. Only one outlet can be used at a time. So, if more than one outlet is used at the same time with EV charging, it is very likely the system will overload. This is why it's critical for level 1 charging to only be done on an outlet with a dedicated circuit. The installation cost for a new level 1 charging outlet is typically going to vary from $500 to $1,500. Moving on to level 2, these EV chargers use a 208 240 volt power source with a range from 6 to 80 amps. Though just because a high amp charger is available does not necessarily mean the vehicle can take advantage of it. Vehicles have their own limits on charge rate via internal equipment, and most of today's vehicles will charge at 30 to 48 amps maximum. On average, this level of charging can provide 20 to 30 miles of range per hour. Also, there are two connector types for this level, which is how power connects to the vehicle. There's the J1772, also called the J-plug, that comes standard on all electric vehicles except for Teslas. Teslas have their own connector type, but Teslas come with an adapter that allows them to charge off a J-plug. All-inclusive costs will vary, but the average is between $3,000 to $5,000. The last type we have here is level 3, which is also called DC fast charging. This type of charging is fundamentally different because it bypasses the vehicle's onboard charging equipment to recharge the battery directly. So charging rates can be very, very quick, sometimes as high as 1,000 miles of range per hour of charge. The equipment can provide these faster charging rates only with huge power requirements and physically large equipment, typically about the size of a refrigerator. Similar to level 2, not all vehicles can accept level 3 charging. Some manufacturers offer it as an option on vehicles. If they can charge on level 3, there are 3 different connector types to know about: CHAdeMO, CCS, and Tesla. It's important to note here that the vehicle and the charging station need to match. Finally, level 3 charging is extremely expensive. The hardware itself starts at around $45,000, and the total cost, including installation, can easily surpass $100,000. Many residents have lived in a single-family home and will have expectations that the charging experience and setup at an MUD or multi-unit dwelling will be similar. So now we're going to walk through the setup at a single family home and typical MUD types to understand the key differences between the two. In a single family home, the electrical system is easy to access. A lot of houses have the electric panel directly in the garage, but even if it is in the basement or elsewhere, it's almost always within 50 feet of the garage or parking location. And since distance is one of the largest factors affecting install costs, keeping it low is key. All power used by the charging station is reflected on the home's utility bill and paid for directly by the homeowner, just as they would without a charging station. It's a very simple electrical system with short distances that allows single-family homes to utilize simple charging solutions at low costs. Ideally, in multi-unit dwellings, you would be able to replicate the single-family home solution. But unfortunately, key barriers stand in the way. The first barrier is access to power. Connecting to an individual unit's panel, which would be ideal so their electrical usage would be reflected on their utility bill, is just not feasible. Reaching the unit's panel from the parking space may be technically impossible, but even if it is possible, it would be incredibly expensive due to the very long distance and challenging environment. Since connecting to the resident's meter isn't possible, the next best option is to connect to the common area power, which itself creates key challenges. The first is monitoring usage. Since the HOA or management pay for the common area power, they will want to be reimbursed for the power used by a single resident, and some additional equipment is necessary to pull this off. The second challenge is power capacity. Buildings are only built with a finite amount of power. Adding more power requires coordination with the utility and can be incredibly expensive, which is why it is imperative to use the available power as efficiently as possible. With the need to provide many charging stations at a building, it is possible to use up all the available capacity. Even with power available, though, the installation of the charging station and routing power from the electrical source to the parking space can be challenging, and it will have a higher cost than a single-family home install by a factor of 3 plus. With different MUD building types, there will be different ideal setups for EV charging. So now we are going to talk about a few setups and the requirements for each. Parking garages are the simplest of all scenarios. The electric room is easily accessible and conduit can be run along the ceilings. And a majority of spaces will have walls or columns the EV charger can mount to. Distances can be long and may require coring through the floors, but most installs in parking garages will range from $3,000 to $5,000. Also, one more thing to note here, this is the hardest environment to get cell service for connected chargers. In an open surface parking lot, the electric room can be very difficult to access. If there is electrical power nearby, you're almost certain to need some kind of trenching and possibly even tearing up concrete or asphalt in order to reach the install location. There will also be additional costs for the hardware, since a pedestal will be required to mount to, since there is rarely a wall or column adjacent to a space. Depending on the lot layout and gaps, there may not be a legitimate location to put a charging station. And if there is, average costs range from $15,000 to $20,000. Very similar to an open parking lot, garden-style or carport communities may find it very difficult to access electricity. In many low-rise buildings with a garden-style lot, there may be very little or no common area power available. If there is electrical power nearby, again, you're almost certain to need some kind of trenching and possibly even tearing up concrete or asphalt in order to reach the install location. Available space within the parking area will be a major deciding factor in install location, since you cannot have charging cables crossing sidewalks, and installing the station directly in the parking space may not be allowed either. The average costs range from $15,000 to $20,000. Your charging setup will also depend on how your community handles the parking experience, whether it be unassigned, valet, or dedicated parking. In unassigned parking scenarios, residents do not have a dedicated parking space and may park wherever they find a spot. This setup provides a lot of flexibility on install location, so you can install the charging stations as close to the electric room as possible. Shorter distance equals lower costs. Stations are typically set up for communal use, where EV owners can charge their vehicles on a first-come, first-served basis and move their vehicle when done charging. This can be a challenging user experience since EV owners aren't always guaranteed access to a charging station. Valet managed parking provides a better user experience for communal charging stations. Since valets can move vehicles around as needed, the residents won't be concerned with moving their car or making sure they get a charge. Charging stations are typically installed in a group near the electric room to keep costs down and allow the valets to easily manage the charging vehicles. Individual charging stations are installed directly in the resident's deeded or assigned parking spot. Dedicated charging provides the best user experience for EV owners, since they are always guaranteed access to their charging station and never have to be concerned with whether or not they will be able to charge. In condominiums, the owners often transfer the charging station with the sale of their unit. And in apartments, when an EV owner moves out, management can then reassign the space to a new EV owner. Now that we've covered the basics, we'll be moving on to talking about our unique solution that EverCharge provides. EverCharge is a hardware and service provider with a solution specifically tailored to MUDs. We provide a Level 2 charging station available with either the J-Plug or Tesla connector. We are actually the only charging provider other than Tesla who can offer their stations with Tesla connectors. Our stations contain the technology to monitor charge events so users can be billed directly by EverCharge and the building be reimbursed for the usage. To differentiate between users in communal and valet situations, we include access control, so we know who is using the station and can bill them accordingly. For dedicated users, they will have peace of mind, knowing no one else will be able to use their charging station when they're away. To help tackle power limitations, we have a power management system called Smart Power that will go into more detail in the next slide. Each building will have its own accessible dashboard for additional insight and serves as a great tool for valets. Aside from our hardware and services, we have a team of specialists dedicated to working with HOAs, management, residents, electricians, and other parties to help navigate the process and implement the right solution for each community. EverCharge's Smart Power technology is key to enabling long-term, scalable charging in MUDs. Smart Power allows for the maximization of the building's infrastructure. It does this by utilizing the available electrical capacity and intelligently allocating that power to charging stations when it is needed. Without EverCharge, charging stations have power blocked off for them, even if they aren't using it, severely limiting the number of stations that can be supported. As we discussed earlier, since EV owners charge for only a few hours every day or every few days, it is not critical to have the power blocked off when the station isn't in use. Smart Power allows for the same infrastructure to support up to 10 times as many stations as a non-managed charging station. This will prevent or dramatically extend the amount of time before the building would need to consider electrical infrastructure upgrades, which can cost tens of thousands of dollars. When planned out, we can greatly reduce install costs, as well as by installing multiple charging stations on a single circuit, providing up to 50% savings on individual costs. All of this that we're talking about right now is only possible with Smart Power. We have been incredibly intentional in our system design to ensure it can function properly even in the most challenging environments, like a multi-level garage with lots of concrete and walls. First, all our technology is built into the charging stations. There is no need for cell repeaters, gateways, Ethernet, or Wi-Fi connections, or central computers. The stations communicate with each other over a robust mesh network generated by the stations themselves, and we program the building's electrical infrastructure into the on-site system. This makes the system very resilient and allows for continued functionality even if a single charging station were taken offline or if the entire site were to lose cell connectivity. We want to make sure EV owners can rely on our equipment even in the toughest situations. Our ability to provide remote software updates ensures the stations always have the newest features and bug fixes. Remote access also allows for troubleshooting and, in some cases, remote fixes that will reduce the amount of service visits and downtime should an issue arise. I hope you've learned something new about EV charging that you didn't know already. If you're interested in learning more, feel free to visit our website at evercharge.net.